All right. Hi. Thanks for coming and chatting with us. Just to get started, do you want to start by introducing yourself and what you work on?
Yeah, my name's Ethan Elasky, and I work on AI debate for Scalable Oversight and Control.
Okay, cool. Yeah, I think I've known that. I've seen a couple of those papers. Are you presenting something this week?
I'm actually not presenting anything this week.
Okay. You're just here hanging out?
Yeah, basically, I got money from Coefficient Giving, which is a nonprofit, and they are funding me for a year to work on AI debate. And so I'm here to talk to a lot of the people who are already working on the area, figure out what's going on, what they're doing in the field, and try to understand their papers a little bit better.
Okay, cool. So I guess have you had prior works on AI debate that you're like bringing to these conversations, or are you like blank slate? Let me absorb as much as I can.
I think that there's some foundational work put out last year by a guy named Sam Arneson, who basically is trying to make debate work. The way that you can think about debate is it's kind of an alternative to traditional RLHF, where in RLHF you have a reward model that is kind of like a teacher model giving reward to the student. And the problem with traditional RLHF or the traditional model is that you end up such that like the teacher model doesn't always understand how to do the grading exactly the best way. And sometimes the student model learns how to cheat and basically work around the teacher model and still get great scores. So think like a student bringing in like a list of memorized answers into a test. The thing that we're doing differently with debate is it's basically like a teacher that's scoring two students, and these two students, one, have the incentive to learn the task properly, but if they catch the other student cheating, then they'll point out wherever that student is cheating, and they'll get extra reward for wherever they point out that the other student is cheating or lying or didn't cite a source or something like that, if you take an academic analogy.
Yeah, that makes sense. What do you think is the sort of theory of change behind this being a tool for safety as opposed to some of the existing other approaches?
I think that it does have like a very strong case for safety in that we want to ultimately be able to supervise debates between very strong AI models. And the idea is that through the process of argumentative clash, but also through certain principles in RL, basically like the equilibrium, if you train for long enough, if you apply the debate process for long enough, is that the students in this setup will eventually learn that, oh, if I cheat, I'll get caught out by the other student. And so my incentives all point towards me being as honest as possible and just trying to complete the task faithfully. And so in this sense, it's almost like we're trying to like train honesty and other desirable behaviors into the model and steer it away from things like lying to us or like making up facts that don't exist, stuff like that.
And what kinds of actual topics are going to be debated? Like in the training process, you're saying, okay, I'm going to have these two simultaneously trained student models. They're going to be debating about something. What is the topic going to be?
We're a big departure from prior work. Prior work is basically exclusively focused on fictional short stories, which are all multiple choice, and they haven't really found that big of an improvement for using debate versus just directly like using ChatGPT to answer questions. What we're doing is we're doing things on math and code, and we're actually having the models generate their own solutions and then verify them using some sort of scaffold, whether that's a code testing system or like a math proof system, to make sure that the answers are actually what the models say that they are.
Yeah, so I guess something I'm curious about, because this is what some of the other reasoning work has been doing too, is like for domains like math and code, those are super verifiable. Like at the end of the day, there is an answer or there is, a correct proof, or there is the bug solved or it's not. I'm wondering about sort of the vast universe of safety problems that are not verifiable. Is the hope that being able to, so I think the reasoning people think that solving the math reasoning problems will generalize to open-ended reasoning. Is it sort of a similar argument for the safety problem here, or is there like a separate path that needs to be done for the open-ended problems?
Yeah, I think that a lot of the same generalization things are things that we're hopeful for. We are hopeful for that, like reductions in lying on math and code or reductions in like basically like unfaithful reasoning. Once that gets trained out, maybe it'll apply to other things as well, less verifiable domains, whether that's like politics, social science, or other things like that. But we're also just generally interested in creating safe systems for people to be able to use untrusted and very strong models for trustworthy cases with. So a lot of like what we're interested in debate is basically allowing models to really go at it on one part of a topic, present their best arguments, which they're incentivized to do via the debate process, and at the end, present the human with more complete information than they would have otherwise been able to have.
Yeah, that makes sense. And what kinds of applications in the long run do you see this being good for?
I think that it really would be good in like agentic coding settings, but also in a lot of non-verifiable tasks as well. There is a huge problem with a lot of the deep research and retrieval augmented generation literature basically how well can models go online, look for sources, judge them as reliable, present them, and then like actually transform them into like a complete synthesis for the user. And to my knowledge, actually some of the frontier labs are already using debate for some of these systems, but we think that basically like building debate to be even stronger and better might improve the quality of, for example, deep research in the long run. So people really can trust the information that they get from AI in depth.
Okay, cool. So I guess you kind of alluded to this, but in a world where, let's say it's like 3 to 5 years from now, every research bet that you've placed actually goes really well, everything pans out. What is new that's available to us capabilities wise or safety wise in 3 to 5 years? What does the world look like? What does new research look like?
Yeah, I think if all the bets that we've placed on debate end up panning out and we're able to see debate scaled to the same level that traditional RLHF or reinforcement learning from human feedback has been scaled out over the last 5 years with things like ChatGPT, Claude, and Gemini, that we will end up with just a ton more honest models that people can trust. And I think that people won't have to suspect language models of constantly being sycophantic and playing to what they want to hear as much as what they do now.
Yeah, that's a great vision. I hope that comes true. Thanks so much for coming to share with us.
Thank you for the questions.